Movements of the Earth. The birth of modern astronomy occurred during the 1500s and 1600s. Scientist Johannes Kepler, who lived from 1571 to 1630, established that the planets revolve around the Sun, thus establishing one of the two primary motions of the Earth. Sir Isaac Newton expanded on Kepler's work, establishing how gravity affects planetary movement. Today, we know that the Earth has two primary motions, rotation and revolution, which are responsible for life cycles of all living things on Earth. Rotation? The first primary motion of the Earth is rotation. The spinning of Earth about/around its axis, the imaginary line around which the planet spins. This movement is called rotation. Characteristic features of this movement are: direction. The Earth rotates in an anti/counterclockwise pattern, i.e. from west to east. We can also say that Earth rotates in opposite direction to the apparent movement of the Sun, from east to west. Duration. The Earth spins on its axis once every 24 hours. It means that it takes 24 hours for the Earth to make one complete rotation on its axis, our definition of a day. Speed/velocity. Because the Earth is a sphere, the speed by which the Earth rotates is different at different latitudes. E.g., speed of the Earth's rotation at the equator, circumference of the Earth at the equator equals 40,000 kilometers. Time to complete one rotation equals 24 hours. Speed of rotation equals distance/time equals 40,000 kilometers. 24 hours equals 1,670 kilometers per hour. Effects of rotation. The resultant effects of this rotation are: formation of day and night. The rotation of the Earth on its axis is responsible for daylight and nighttime. The Earth is a sphere, so the half portion which faces the Sun experiences day and the other half portion that stays away from the Sun experiences night. As the Sun rises from our perspective, we are rotating to face the Sun. Conversely, the Sun sets as we turn away from the Sun. Difference of time. As the Earth takes 24 hours to make one complete rotation on its axis, a very important effect that results is the change in international time throughout the world. During these 24 hours, 360 longitudes pass across the Sun, which creates a difference of exactly 1 hour per 15 degrees of longitude. 360 24 equals 15. As the Earth rotates in west to east direction, the time after every 15 degrees longitudes in the east is 1 hour ahead than west. Coriolis effect. When the Earth rotates on its axis, it prevents air currents from moving in a straight line north and south from the equator. This deflects winds to the right in the northern hemisphere and to the left in the southern hemisphere. This is called Coriolis effect, named after the French physicist Gustave Coriolis in 1835 who discovered it. Revolution. As the Earth rotates on its axis, it also revolves in an orbit around the Sun. This movement is called revolution. Characteristic features of this movement are: direction. The Earth follows a circular path as it travels around the Sun in a counterclockwise pattern. Duration. It takes exactly 365 days for Earth to make one full trip around the Sun, our definition of a year. Speed/velocity. Speed of the Earth's revolution around the Sun. Radius of the Earth's orbit equals 150 million kilometers. Circumference of the Earth's orbit equals 942 million kilometers. Time to complete one orbit equals 365.2422 days equals 8,766 hours. Speed of revolution equals distance/time equals 942 million kilometers. 8,766 hours equals 107,000 kilometers per hour. Effects of revolution. As the Earth revolves around the Sun, its axis is tilted from perpendicular to the plane of the ecliptic by 23.5 degrees. The angle/degree of this tilt is known to change over time. It can be at a maximum of 24 degrees and a minimum of 22.5 degrees. It is on this axis that the Earth rotates every 24 hours. Since the axis is tilted, the effects of revolution of the Earth is different for different parts of the globe. Certain areas are tipped towards, or away from the Sun at different times of the year. This tilting causes the 4 seasons of the year. This tilting also creates opposite seasons in the northern and southern hemispheres. Seasons. Summer solstice. On June 21st Street, the northern hemisphere is tilted towards the Sun. That's why the days in northern hemisphere are longer and nights are shorter. As a result, there is summer season in the northern hemisphere. On the other hand, conditions in the southern hemisphere are exactly reversed. Winter solstice. On December 22nd, the northern hemisphere is tilted away from the Sun. That's why the days in northern hemisphere are shorter and nights are longer. As a result, there is winter season in the northern hemisphere. On the other hand, conditions in the southern hemisphere are exactly reversed. Equinoxes. Midway between the summer and winter solstices, on March 21st and September 22nd, neither the northern nor the southern hemisphere is tilted towards or away from the Sun. That's why the days and nights are equal in both hemispheres. As a result, there is spring season on March 21st and autumn on September 22nd in the northern hemisphere. On the other hand, conditions in the southern hemisphere are exactly reversed. Thanks for watching.